So before we get started, I just wanted to introduce myself. So my name is Michael Crilly. I live here in Brisbane in Queensland, Australia. I'm originally from England. That's probably why you can pick up a little bit of an accent there. And I've been in automation for about 5 years now. Back home in England, I worked for UK Fast, Rackspace, Skyscape, now known as UK Cloud, the DVLA, the Department for Work and Pensions, and then I shifted over into Australia, where I've worked for a lot of private sector companies, some startups, as well as the public sector, such as the Queensland Police Service and the Queensland Treasury. And all of those jobs involve some form of automation. In the very early days, it was very little automation, but then as time went on, organizations realized that automation was a very key component into speeding up and safeguarding a lot of the processes that go into operations, go into building infrastructure, building operating systems, and delivering software to end users. And so most of my experience here in just Brisbane alone for the past 5 years has been, how do we take operational processes and how do we automate them? And I've used tools such as Kubernetes, Docker, Rancher, Console, Vault, Terraform, Ansible, Salt, Puppet, CloudFormation, and I've worked in AWS, Azure. I've worked in all kinds of public cloud environments using all kinds of technologies, but the end goal has always been automation. That's been my life for the past 5 years. And so I'm hoping that I can draw on the last 5 years in order to help you better understand one of the key components in the tool chest that is automation, and that's continuous integration and continuous delivery. Okay, so in this series of videos, we're going to be looking at continuous integration and continuous delivery, which is effectively the process of automating software delivery. So it includes several things, and we're going to step through them. But first, we're going to start by actually looking at these processes if they were to be done manually. Okay, so what does the manual process look like? So this will effectively describe the problem for us before we then move on to what the automated solution looks like. Okay, so it all begins with a developer. Okay, so we have a team of programmers who are looking to write the best code that they can in order to meet their goals, in order to implement new features into our enterprise grade software. Okay, that's for example. Okay, they're also going to write some tests as well, different types of tests for different types of things. What they're going to do now is they're going to take the software that they've written and they're going to apply those tests to it. And again, these could be unit tests, these could be module tests, there could be lots and lots of different type steps. There could be a handful of tests, maybe there's only 5 or 6 of them, or maybe there's 5,000 of them. Okay, there could be UI tests as well. You could be running something like Selenium to check that the UI you've implemented meets expectations. Okay, and they're also looking for things like regressions as well. Are the features that we're implementing here going to regress or affect or break an existing feature? Okay, so testing is actually quite an important part of software development, and they're going to obviously make sure that, so essentially the end goal is to make sure that their software is healthy software. Okay, it's healthy for the business and it's healthy for the end users and it meets expectations. So once they've done that, they're now going to compile and package up their software. And that could be, it's some kind of artifact, right? It could be a jar file, it can be an executable file, it could be a Windows executable, it could be a Linux executable, it could be a Unix executable, right? But they're essentially going to produce some kind of artifact that will then be passed on to the next team, okay? And they're going to push this artifact to potentially a Maven repository, or it could just be an FTP server, or it could just be a web server, or maybe they even just email it to the systems team. That would be probably a bit crazy. You're probably not going to see that in the wild, but who knows, right? It's just an artifact. The developer has written the code, they've written some tests, they've then ran the entire test suite against their software, they're happy, so now they've packaged that up into some kind of artifact that's ready to be passed on to the next team. And so we have a team here of engineers, these are system engineers, and these engineers are going to take that package and get it ready for deployment. So the package will need to be deployed across a network of servers. It's very unlikely you're going to have one application server. In most enterprises, you're going to find a level of redundancy. So they've now got to deploy this package manually to several of these servers. Okay, and ideally they need to do this with a degree of zero downtime for their end users. So the end users should simply just see the software just magically pop up and a new version just appear. They don't see any interruption at all. At least that's the end goal. You don't always get there, but it is possible. There's also configuration updates that this team needs to do as well. Okay, so the new features will require new flags to be set in a config file, so those config files will need to be updated on each server. And of course, you've got things like database migrations as well, so that's changing the actual structure of tables in relational databases, or perhaps you're using NoSQL and you don't really need to do any database migrations. It really does obviously depend on the software. But essentially, this team are going to take your package and they're going to push it forward and they're going to make it live, okay? And they're going to do that by deploying it. So all the configs have been updated, any database migrations have been completed, and the software is now launched and has now gone live, okay? And people can now start using the software. Okay, so the developers have written their code, written their tests, and ran those tests. They've packaged it up. The deployment team have got all the configs ready, got all the migrations ready. They've executed them all, and now everything is live. We have liftoff, if you like. So you're now going to see the quality assurance teams checking the software that's now live, making sure it really does work as expected. And you're going to be seeing the customer service team looking out for tickets or calls from customers saying that something has stopped working. Okay, we have an issue. Okay, so we may need to roll back or roll forward depending on what your development methodology is. Okay, but in our case, we're just going to say that everything seems to be fine. There are actually two very important points to be made about this entire manual pipeline. Okay, so we've gone through this pipeline of writing code, writing tests, running all of the tests, which again could be 5 tests, could be 5,000 tests. We've then packaged that up into some kind of artifact. We've given it to the systems team, who've then got everything ready, configuration files, database migrations, and they've made all of that live, so they've deployed it. And then we've got another team of people, maybe the developers again, are now testing the live system just to make double sure that everything's working as expected. And we've got our customer service team on standby as well, looking out for complaints or issues from customers. Okay, but here's a question for you. How long did all of that manual work actually take? How much time was involved in making all of that possible? Right. How long did it take for the developer to test the software? So if there was 5,000 tests, how long did that take? How long did it take to package the software and the deployments as well? How long did that take? Again, there's multiple servers to be updated. They've got to be done in a way with ideally with zero downtime. That could be a company policy, in fact. You've got config files, you've got database migrations, and what happens as well if the deployment actually fails and you need to roll backwards? How long does that take? And how long does it take before the issues start coming to the surface? So you've deployed, everything looks right to you, but what if in 3 days' time, a very small feature that's only used by a small subset of your clients went into a state of regression and actually broke? How long will that take to surface? 3 days, 5 days, 3 hours? And of course, yeah, what if problems are introduced because of course you missed something in the testing phase? Okay, what if a developer actually missed some critical tests? Okay, what if tests were done incorrectly? What if they weren't actually done right? They all showed everything as working as expected, but what if in actual fact the developer missed certain critical tests? Okay, or they weren't done correctly? And what if, again, there was a regression introduced into the software, or your feature was faulty and your tests weren't developed correctly? Well, here's another question for you. What is actually, when you look at the processes we've just described, what is the biggest common factor between all of these processes? Okay, what is the one thing that is present throughout all of the steps we've taken to deliver this new software? It's people. People are involved in every single one of the processes that we've just described, and there's a bit of a problem with people, and that's that they get tired, they get emotional, they can be lazy, they can be ignorant of a new process or a new method that your company may put a policy in place to say you have to do this thing. They may not get that communication, so they may not do that thing, or they could just outright ignore your instructions. Unfortunately, people, we're quite emotional creatures. We sometimes believe that we're above those instructions, and so we may choose to ignore them. Or you may just actually forget. You might receive some instructions in an email, or you might receive them socialized through a meeting, but you may just not heed those instructions. You may forget to heed them. And so the weakest link here is obviously the people that are involved, right? It's the people that take the most time to work their way through these processes, okay? And it's people that result in these processes failing and entering a broken state, okay? Because they forgot to do something, they didn't know to do something, or they did something incorrectly because of things like fatigue or emotional upset. So what's the best way of automating the processes that we've just seen? So we've just seen all of these processes done manually, but what is continuous integration and continuous delivery? It's taking all of those steps that we've just looked at and doing them automatically. And so what is the best way of doing that? It's by utilizing robots effectively, is what you could arguably call them. Okay, they're a good analogy. We as a species, we're in the process of automating so much, and robots are going to be eventually something that enters our daily lives, because we program to do the tasks that are things that we're potentially bad at doing in a repeated manner. And that's where continuous integration and continuous delivery come into it, because robots can perform whatever task we need automatically, consistently, every single time without failure. And so we come back to the beginning, right? We have our team of programmers that aims to write the best code that they can. They're going to meet their goals, they're going to implement new features, and then they're going to write some tests. But now this is where it changes, because now they're going to push their code to a central repository such as Git. Git is the most likely the system that you're going to see live out there in the enterprise, okay? And then what they're going to do is they're going to move on to another task, or they're going to go to a meeting, or they're going to go and grab a coffee or something, okay? Because at that point, their work is actually done, because the testing is now being done in a continuous integration pipeline, as it's referred to. And that's where our robots come in. Our robot is now going to run all of our tests for us, like the developer doesn't have to do it now, right? And because they're being done automatically, they're not being done manually anymore, that means that no tests are skipped unless you define some logic to skip them in some predefined circumstances. Some situation warrants certain tests being skipped. That's fine. They will be skipped if those circumstances are met. But the tests also won't be forgotten. Okay, once they've been written, once they're in place, once they're inside the continuous integration pipeline, they won't be forgotten, and they won't be half done because of fatigue or emotions. The robot doesn't get fatigued, and the robot doesn't get emotional. It just runs the tests over and over and over. What's after our tests are complete? Well, of course, we package the software up, but this is also being done for us as well by our little continuous integration robot. We don't have to do this manually, which again means that the application is compiled correctly, and so it performs as best as it can in production with the right compile time flags, for example. You won't get the wrong artifact. We'll get the exact artifact we expect. So if we're expecting an executable, the wrong process won't be executed and you'll end up with a jar file. You'll get that executable every single time. The correct version number will be applied to the new artifact, so the version number will automatically be incremented, and it'll automatically be stored in the right system for us as well, so it won't be uploaded to the wrong point, and there won't be then some confusion from the systems team as to where the artifact has been deployed, and they go hunting for it and they have to come and ask you questions. Okay, so we've got the right version software in the right location. And so that's the end of the developer phase. What about the systems phase? What about the systems team that we saw earlier, the two engineers at the computer? They're out the picture as well, okay, because continuous delivery is doing their job for them. Okay, they're still in the picture in the sense that they're the ones that develop the continuous delivery pipelines. However, once they're in place, we've got our little robot that deploys our software for us, and it knows the correct version, right? The version number that we've just said is the correct version number, gets passed through to the continuous delivery pipeline. That means that the correct version software gets deployed to the exact correct environment every single time. If it was meant to go to staging, it will go to staging. If it's meant to go to production, it will go to production, right? The deployment steps will be executed in perfect order every single time. The computer isn't going to get fatigued or emotional, and so nothing will be overlooked or skipped in any way, shape or form. The computer will just do its job each and every time. Once it's now deployed, we had that testing phase, didn't we? We had our customer service on board, and we had our QA team as well. Well, our continuous delivery pipeline can also do some testing for us as well. So once the software has gone live, we can actually get it to do some testing for us. It can do some system testing, some UI testing. That doesn't mean the customer service department just is no longer useful. Of course, they're still useful. Of course, they're still going to look out for tickets and calls from clients. But now that QA team can develop automatic tests that are run every single time as well. And again, unless you define some logic to skip tests, none of them will be skipped, none of them will be forgotten, none of them will be half done due to fatigue or emotions again. The tests will just be run perfectly every single time. All of this is because what we have now is this pipeline. Okay, from top to bottom, we have this pipeline of testing, packaging, deploying, and then testing. Okay, this is referred to as a pipeline in the CI/CD world, and these pipelines contain all the steps necessary to test the software, package it, deploy it, and then test that deployment. Okay, and it's all pipelines, generally speaking, are fully automated end-to-end. You push your software, and this entire pipeline executes. And this comes with benefits. Okay, let's say for a second that the tests fail. Okay, the tests fail. The tests detect something is wrong. Okay, we've tried to ship faulty code. Well, the pipeline prevents that faulty code ever reaching our end customers, because the moment the tests fail, the pipeline halts. And where do we end up when the pipeline when the pipeline halts due to a failure? Well, we end up back at the developer, because now the developer will be made aware of the failure. They'll be given the details of the failure. The pipeline will contain logs as to what failed with error messages from the test suite. And then we start at the beginning again. The developer will then look at the code, they'll write a patch, they'll then push that code to the repository, and the whole life cycle of the CI/CD pipeline or pipelines will start from the beginning again. Simple as that. So what we're going to do now is we're going to look at an example. So I'm going to review a very, very simple example that I've already developed ahead of time, and it will just be a very small application written in Golang. It'll just be a small little command line utility with some simple functions and a very simple pipeline that does our testing for us and a sort of fake deployment. And what we're going to do is we're going to see the pipeline in a working state, and then we're going to break our code on purpose, push it to the pipeline, and then we're going to see the pipeline fail. And then we'll get a good idea visually of what a CI/CD pipeline, a very basic one, looks like in the real world. Okay, so what we're going to do now in this video is we're going to look at the example code and an example pipeline. Now, if you remember from when we looked at the manual process, we talked about how our programmers would write some code, they would write some tests, then they'd run the tests themselves directly. They would then package the software up, and they'd give that package, that artifact, to the systems team, who would then deploy it across the network. And then we'd have our QA team do additional tests, and then we'd have our customer service team looking out for tickets and problems coming in from customers. So we're gonna look at a similar process. We're gonna skip the deployment side of things. We don't really need to go into any detail on that. However, we will look at some code and some tests. So what I've got up here on screen is just a plain GitLab repository. It's got 3 files in it. The .gitlab-ci.yaml, YML means YAML, which is spelled YAML. That's our CI/CD instructions, so we'll come to that shortly. We've got our example.go file, and we've got our example_test.go file. So you can probably imagine what these do in terms of what they're for. That's actually our program. So if we take a look at our example.go, it's a very simple piece of code. It's not really doing anything overly complicated. All we're doing here on line 21 is we are taking in the arguments from the command line. We're just skipping over the very first argument. That means the first argument is usually the actual path to the binary itself that we executed. We're not really interested in that, so we're gonna slice over that. We're just going to do a quick check. We're going to say if you didn't provide any arguments, then we're going to call our say hello function with the string stranger. And then if the length is actually greater than 0, then what we're going to do is we're going to call a function called bounds check on that argument. We don't want the string to be any larger than 12 characters. And then we're going to call the function say hello with the results from the bound checked function. Okay, so what are these functions? So the nature of this application is just about taking in a string, so a name, because obviously we're saying hello here, so it's going to be a name, ideally. And then we're just doing a few little simple functions just to make sure that the name isn't too long. So what are these two functions then? So we've got our bounds check, which takes a string and an integer and returns a string. And all we're doing is saying if the length of the string is less than the bounds, then we just return the string itself. Otherwise, we slice the string. So we kind of slice off anything that goes beyond the bounds. So if it's 16 characters, but we want the bounds to be 10 characters, we'll get back a 10 character string. And the other 6 characters will be sliced off the end. And all the say hello function does is just use a string format in order to say hello, and then whatever string we pass in. So it's very simple, very similar to a hello world example, except we're just saying hello, and then whatever, Mike, Chris, Michelle, whatever that is. So I'll do a quick demonstration of the app actually executing here on the command line. So if I just do go run example.go, it says hello stranger. Now that makes sense, right? Because we didn't actually pass anything. But if I pass in a string, then we get hello Michael. Now if we look at the string Michael, we've got 1, 2, 3, 4, 5, 6, 7 characters in there. Yeah, 1, 2, 3, 4, 5, 6, 7 characters. So that means if I do that twice, I've got the default code set up with a bounds check of 12, and obviously 7 plus 7 is 14. So what will we get back? So as you can see, the E and the L was chopped off the end. So that's just a quick example of what our application actually does. Very, very simple. Not really anything to write home about. Okay, so what does our example underscore test do? So we've written our code now. We're that programmer. We've written our code, and now we've got to write some tests because we've got to check that those functions do what we've said they do. So we've got 2 tests in here. The first one here will test that the bounds check function is doing its job. So we've got this, let's just say an array. We've got this array of tests here where I'm going to feed in the string Mike with a bounds check of 12, and I expect to get Mike back. The same with Chris, string of Chris with a bounds check of 12, and I expect to get the string Chris back. Now here we've got a series of numbers in order. We get through to 10 numbers, and then we've got an additional 3 on there. Okay, so that's 13 characters in this string with a bounds check of 12. What we expect to get back is 12 characters. So we expect this 3 to be chopped off the edge. The same here as well. We've got the string Michelle with a bounds check of 4. So we expect to get the first 4 characters back, and so on and so forth. Here's my name with a bounds check of 10. So we expect to get 10 characters, and so on and so forth. And all we're doing here is we're just looping over those entries here, and we're just calling the bounds check function directly. We're passing in the values. So passing in the name, the first string, the boundary check, which is the integer, and then we're just checking to make sure that the result we got back from the bounds check function matches what we expected here. This is the expected string, and we're just looping over them. We're looping over all the entries, that is. So now we've got a second test function, which is the say hello function, which, as we know, takes a string and then it returns hello, comma, space, and then that string, right? So we've got Mike, then we've got hello Mike. That's what we expect to see. We've got John, we've got hello John. That's what we expect to see. Chris, hello Chris. Now this is very simple. Again, we're just looping over. We're passing it in this thing, and we expect to get this thing back. So results equals say hello. We're passing in the string, and then we're basically saying, did we get back hello Mohammed? And if we didn't, then we throw an error. And we're doing the same up here as well. If the result doesn't match, then we throw an error. Okay, so as a programmer, we've written our code, and now we've actually written our tests as well. So now if we say to go, hey, pop into this directory, I've got some tests in here. I want you to tell me if those tests are passing. So let's find out if they are. They are. What I can actually do as well, because of the way I've set these tests up, I can actually get a little bit more detail by going into verbose mode, and we can see each test being executed here. So we can see there's our test cases here, and we can see that they're all passing. Great. Okay, so that's great. So what the programmer would do here now is they do a go build. In this case, they get an executable, and then they pass that to the systems team, and off we go. We've got our working software. But what we want to demonstrate is a failure, don't we? We want to see a failure. So if I go into the example_test file, actually instead of going into the test, my apologies, if we actually go into the example.go file, and what I'm going to do is on line 12 here, I'm actually just going to say ignore the last character of the string. So take the length of the string and then just knock one off it, because there might be a new line on the end. We don't really want to do a bounds check on that, right? So we write that out, and then we do our go test, and we have a fail. So we have a fail because, of course, we've knocked that end value off, and now it doesn't actually match. It doesn't actually work as we expected it to. So I'll let you review the code and work out why specifically these tests fail. But the important thing here is that our tests have actually caught this problem. And so now what I can do is go back into my code, go back to line 12, and then I can take that mistake that I've put in there. Oh, actually, I don't want to do that because that doesn't give us the results we're looking for. I can write that out. I can run my tests again, and now my tests pass. So I can compile my software, and I can pass that over to the systems team. But what happens now if we want to use CICD? Because that's obviously the point of these videos, right? We want to demonstrate CICD. So we've got our GitLab CI file here, which is extremely simple. It's very basic. This can be really, really complicated. It can be really, really powerful. But in our case, we just want to demonstrate a pipeline going through the system. That's all we want to look at. So all we're saying here is use the latest Golang Docker image. So the GitLab runners, the shared runners that GitLab give you for free, use Docker-based runners. So we're saying go out and get the Golang image, go and get the very latest version of that image. And all we're saying is we've got a stage called test, and we're telling it we want you to run a series of scripts, and we just have one script in here, which is exactly the command we've been executing on the command line. It's go test -v. And so this is the point I was making earlier in the earlier video when I was going over the concepts of CI/CD, is we're building a robot, and we're getting the robot to do the tasks that we would do. We're getting it to do the tasks for us because we want to automate away those tasks. We don't want to do them because we don't want to do things that we could make mistakes with. We don't want to skip tests. We don't want to forget to do certain tests, but we want to avoid making mistakes if we can during the testing and development phase to the highest possible degree, and that's where CI/CD comes into it. So this simple script will trigger every time we push some code. So let's do that now. So we don't have a readme file in here, right? So let's go readme.md, and we're just going to say go CICD example, and then we're just going to say this is an example CICD repository. Okay, we're going to write that out. We're going to add that to Git. We're going to get Git to track that file. In fact, I'll show you what that means very quickly. Again, this isn't a Git or a Go tutorial, but we'll look at it. So we're on the master branch, and we've got an untracked file here. So we're going to add it, and then we're going to commit it. So we're going to commit this, adding readme. So we've added in one file, and we've got 3 assertions as well. And so we're going to push this up. So Git will now push that to the GitLab repository. We'll see now that we've actually got our readme file now. It got added 42 seconds ago. We've just done that. There's our contents. But here's the important part for us, is that in our CICD here in GitLab, we can see that adding the README, which was our commit here to the master branch, triggered the pipeline. That's CICD in action. It's automatically triggered because we pushed up some information to the repository. And you can see here, I've been doing it previously as well to make sure this all runs so that you guys get a nice smooth demo. Now, if you look here, it's finished and it passed. Our tests were actually successful. So there's our stage. Remember I said we had a stage called test. There it is. And there's our tests. There's our script, go test-v, and there's all the individual tests all executing. But what we want to do is we want to detect a failure, right? Don't we? Because we did that earlier. We did our change to our code, and that actually resulted in a failure. Now, as a developer, what we could do is we could work in a way where we just kind of go, okay, well, I'm just going to write some code. I'm not even going to run my tests locally. Okay, I'm just going to go, let's not check for new lines. And then I'm just going to push that code. And then I'm going to walk away. Okay, I'm going to do what I said earlier, is I'm going to go and grab a cup of coffee, or I'm going to go for a meeting now. That's because in our CICD, if I come back to pipelines, we'll see here that a pipeline, again, as executed based on our commit here to the master branch. A pipeline has now executed. If we come over to that pipeline, we can see that we have a job running, test. So there's our job under the test stage. We pop in here, we'll see the Docker container, as I said earlier, the GitLab runners, the shared runners that gitlab.com gives you for free, uses Docker-based executors. And so it's now pulling in the image, it's pulling in the Golang latest image, all automatically, all for free. All we've done is written 4-5 lines of YAML in one file, and we're getting all this free. And as we can see, we've done our go test-v. Notice how here on line 16, it's go test-v every single time. That's what's important, right? Because we are executing the go test-v. That's what we want every time. We want that every time, so that we're seeing in the logs every single test and we're making sure that they're all passing. Now, obviously, in a larger environment, a larger project, your tests would be far more complicated, and you'd want to make sure that they all execute. And so by programming a continuous integration, in this case a continuous integration robot, we make sure that all of the tests are executing each and every time without failure. Nothing's being skipped. We don't need a checklist of items that we've got to tick off and go, did I run these tests? Did I run these tests? Did I run these tests? We just do this once. We push our code, and the CICD pipeline takes over for us and executes it for us perfectly every single time. And as you can see here, it's gone ahead and done go test-v, and as you can also see, we've got our failure. So here's our failed test bounds check with table. So what failed here? Example test 23, that string does not equal that string, and that was because of the error that we introduced into our code. And so the pipeline exited with a status of 1, which in the Unix world means failed. 0 means success, and anything other than 0 means a fail, including negative numbers. And so that is a basic demonstration of how pushing code to a CI/CD pipeline, once you've written it, allows all of your tests to just automatically be executed, the software to be automatically packaged and automatically distributed out into the network and made live. And this here, what we've got, is obviously an extremely simple demonstration, but it shows our pipelines working as expected. So we'll do one more change. We'll come in here and we'll undo what we did earlier, right? So we'll get rid of those 2 characters there. We'll do this, and what we'll also do as well is we'll actually add in another test case as well. So if we come to here, and we can go Jeff with a bounds check of 4. So what should we get back? We should get back Jeff. Okay, because Jeff is 4 characters. We want a maximum of 4 characters. And so we should get Jeff back. Let's just double check our code to make sure we're actually committing what we expect. So we've got our if statement here, which has been put back to the way it was previously, the way it should be, and we've added in an additional test case. So let's go ahead and commit those, and we'll just say that we're testing our pipeline again, and it's pushed. And then we'll go here, pipelines, there's our pipeline, into our stage, which was the test stage. We should see Jeff, there's Jeff there. So there's our Jeff test case, additional test case has been added in and is successfully passing. And so that is a very basic demonstration of some simple Golang code being executed automatically in a pipeline with our tests the moment we push it to the remote Git repository.